In this video, we'll be looking at the basics of graphing sine and cosine functions, and we're going to identify the major components that we need to look for and document those on the sine and cosine parent function. And then in part 2, we'll start actually graphing. So mainly we're focused right here in this area for now, and you can see we have sine and cosine here, and we have all of these red underlines, and we're going to be discussing what each one of those does. So the A value, that's this one here on sine, this one here on cosine, it's the multiplier in front, and that is called the amplitude, and that gives you the height from the middle. So it says how far does it reach above or below its central horizontal axis. So whatever this number is, that's how far above and below the midpoint, the midline, that the peaks and valleys of the sine or cosine waves go. So if that's 2, it'll be 2 above and 2 below. If it's 1, it'll be 1 above, 1 below. So let's pan over here and look at the sine and cosine and label that. So on the parent functions, this amplitude would be this distance right here. So from here to here is 1, and you have the same thing down here. So the amplitude here would be 1. It's this distance right here. It's not the whole thing. It's not from here to here. That would be twice the amplitude. The amplitude is just from the midpoint to the peak, the midpoint to the valley. And same thing on cosine here. You're measuring, the amplitude is from here to here, and it's going to match here to here. It's going to be equidistant from the midpoint. The amplitude is equidistant from the midpoint to the peak, midpoint to the valley. Next important part is the period of the graph. And the period of the graph is how long does it take to complete a full cycle. And we'll look at that in a minute. When you're looking at the function itself, you can determine what the period is by taking 2 pi and dividing it by this b value, this multiplier in front of your theta or your x. We usually use theta when we graph instead of x, but it's the multiplier in front here. So 2 pi divided by whatever that value is. So let's look at the sine and cosine parent. By the way, this was sine theta, and this is cosine theta over here. So let's talk about what the period of the parent function is when you begin. The b value here is just 1. Notice there's no multiplier in front of theta here. There's an implied 1 there. So the b value would be 1, so the period is 2 pi divided by 1, or just 2 pi. So what does that mean? Well, you can pick any point. Usually you should pick either a midpoint or a peak or a valley. And by the way, I call this the peak, this the valley, and then here's a midpoint right here. So that's the vocabulary I'm using. So with sine, we'll start right here at a midpoint. So it's coming up through its midpoint right here. So the next time it comes up through its midpoint right here, we measure that distance, and that gives us the period of the graph. And notice it starts here at a theta value of 0 and stops, or completes, I should say, at a theta value of 2 pi. So that distance is the period of the graph. So from here, from there to the here is 2 pi. So the period of the graph is 2 pi. Notice it comes through the midpoint here, but it's on its way down. So that doesn't count. It's on its way up through the midpoint right here, and the next time it's coming up through the midpoint, that's where you measure. And it wouldn't matter if we measured from, for example, valley to valley. If you were to take this distance from this valley to this valley, that would be the same thing. That's going to be 2 pi. If you measure from this peak to this peak, it's still going to be 2 pi total. Each one of these little vertical grid lines that you see here are pi over 2. So it's half pi. So we have 1, 2, 3, 4, 5 of those. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So that's 2 pi distance. It doesn't matter if you measure peak to peak, valley to valley, midpoint to midpoint, as long as the midpoint is on its way up, and its way up, then it counts. You can't measure on its way up through the midpoint and then on its way down. That's not going to give you the right value. You have to measure from midpoint in the same direction on the way up, or peak to peak, or valley to valley. Gives you the period. All right, so let's look at the cosine graph. And I know I was a little wordy there, so let's try to make this a little simpler. So let's measure the cosine graph. The cosine graph is going to be easier in this case to measure from peak to peak. And you notice it's from 0 right here all the way to 2 pi over here. So that period is 2 pi. From peak to peak, 2 pi. We could measure from midpoint on the way up to midpoint on the way up. Or we could measure midpoint on the way down to midpoint on the way down. Either way, we're going to get 2 pi. That's going to repeat over and over and over again. That's how long it takes to complete a full wave. All right, next part, let's look at the vertical move. So just like all other functions we've worked with all year, the vertical move is out away from x and it's with the sign. So a plus here moves us up, a minus here moves us down. So an addition is up, a subtraction is down. And that is the vertical movement. So if we look at the sine graph, it's not moved up at all. It's midpoint, it's midline. Its midline is right through here, and it's on 0. So no vertical movement there. If we move it, this whole thing, this whole wave here, this whole wave is going to shift either up or down. So the midpoint, the max line, the midline, the minimum line, all would move up. So the whole graph moves. You can't just say that the peaks move, or just the middle moves, or just the min moves. They all move in conjunction together vertically when you have an addition or subtraction outside away from x. All right, let's look at the next part. Okay, the next part is the horizontal movement. That's called the phase shift, left and right, and it's opposite of the sign, just like all year. When we're left and right opposite, when we move left and right, it's opposite of the sign, and that value is inside the parentheses with your x, or in this case, the theta value. So that's going to be a horizontal move. So that would just take everything, the whole graph, and shift it either right or left. So it's right when c is greater than 0, and it's left when c is less than 0. Now notice they have a subtraction here. So the easy way to remember it is left and right opposite of the sign. So if you have, say, a plus 5 there, then that's going to move it left 5. If you have a subtract 5 inside here, it's going to move it right 5. So it's always opposite of the sign. And we'll look at some of those examples later. It is technically, if you have a multiplier in front here, you have to divide by that value. So that will affect it if you have a multiplier in front. All right, next we want to look at, this will actually be the last thing, the step. And this is what I call it, the step. And what it does is it helps you when you start graphing these transformations. And the step is the period divided into 4 equal pieces. So you take the period, you divide it by 4, that gives you the step. So what does the step do? So let's come over here and look at this. The step does this. It tells you how far from a peak to a mid, or a mid to a min, or a minimum to the middle. In other words, every time you step, so let's say we start here, it doesn't matter, let's say we start here, we're at a max. So the step value tells us how far it is to go to the next important key point. And if you look at the parent function, I talk about the 3 M's. That was the max, the mid, and the min. So the step value gives you that distance. So in other words, if I start at this peak right here, and the step value tells me how far it is to the middle, and then how far it is to the min, and then how far it is to the middle, and then again how far it is to the min. And those distances are all equal. In this case, the period of the graph is 2 pi. So if we take 2 pi, we divide it by 4, reduce that, it's pi over 2. So you notice each one of these steps between a middle, a min, or a max is always pi over 2. That's what the step does for you. And when we start graphing, it'll make more sense. So that is it for this video, and in part 2 we'll actually start making some transformations to the sine and cosine parent functions.